Let's show that 6 minus root 8 over root 2 minus 1 can be written in this form, a plus b root 2. And we also need to be aware that a and b are integers. So real quick, if I want to rationalize the denominator, I will have to use the conjugate of root 2 minus 1. What is the conjugate? It is root 2 plus 1. So when you have minus here, the conjugate will be plus. But if this were plus, the conjugate would have been root 2 minus 1. So it's like minus to plus and plus to minus. So I'm going to multiply the numerator and denominator by the conjugate of root 2 minus 1. Again, let me just quickly add that if what you are trying to rationalize is, let's say, root a plus 5, the conjugate will be root a minus 5, because this is from difference of two squares. As you can see now, this is root a, this is root a. This is 5, this is 5, this is plus, this is minus. If you want to use difference of two squares, it's going to be root a all squared minus 5 squared. See, difference of two squares. Hey friends, do you want detailed, structured, and easy to follow math lessons? Join the GPAD Maths Academy, link in bio. That's the reason behind using the conjugate to rationalize. Because if you do this, you see it clears up the rational symbol. You just have a minus what, 25. Now quickly, let's go back to this question before us. So I'm going to have what, 6 minus root 8 over root 2 minus 1. Like I told you, we're going to multiply by the conjugate of the denominator. So you have root 2 plus, from minus to plus, so that it will have the form of what? Difference of two squares. Now you have to multiply the numerator by the same thing here. So root 2 plus 1. It's time to expand. Now, I am not even going to stress it for the denominator. Just use difference of two squares like I earlier explained. So you have 6 times root 2, which is 6 root 2. And then 6 times 1 is what? 6. Root 8 times root 2 is what? Root 16. Because 8 times 2 will give you 16. Then you have minus 8 times 1 is what? Minus root 8. That's minus root 8 times 1, minus root 8. So I will have 6 root 2, okay? And then what? Plus 6. What is root 16? That's 4, because 4 times 4 is 16. So that's minus 4. But what about root 8? Do you know that root 8 can be expressed like this? 4 times 2. I'm trying to reduce it. 4 is a perfect square. And the square root of 4 is what? 2. So you have 2, then root 2. So I'm going to replace root 8 with what? With 2 root 2 minus 2 root 2. Okay? And all divided by, this square will cancel the square root. You have 2 minus 1, which is still 1. So I can as well remove everything here and just have this. So let me just rearrange the terms now. This is 6 root 2. Like terms, move negative 2 root 2 to this place. And you have 6 minus 4. Okay? Now look at this. 6 root 2 minus 2 root 2. They have common radicand. So we can add, we can subtract, because they can be categorized as what? Like sorts. Just as you add and subtract like terms. So you just simply subtract the coefficient of the sort. So 6 minus 2 is 4. So you have 4 sort 2 or root 2. 6 minus 4 is what? 2. So this is the result you get when you write it in this form, a plus b root 2. But finally, we'll just write 2 first, because we have a, which is an integer, then plus 4 root 2. So we can say, therefore, that what? A is 2, and then b is what? 4. I'll see you in the next video.